In this exploration of brain science, we dive into the fascinating mechanisms that allow us to manage pain and accelerate healing by leveraging the power of the brain, as Dr. Andrew Huberman, a neuroscientist and professor at Stanford University, might explain. The brain is not just a passive receiver of sensory input, but an active participant in shaping our experience of pain and recovery. This summary, inspired by Huberman's approach, breaks down the science of pain perception, the mind, body connection, the role of neuroplasticity, practical strategies for implementation, and the scientific evidence supporting these concepts. By understanding how the brain processes pain and how we can influence it, we can unlock tools to reduce suffering and promote faster healing. This 4,500-word summary aims to provide a comprehensive, accessible guide to these ideas, grounded in neuroscience and practical application. Understanding pain, the brain's role in pain perception, the complexity of pain. Pain is not just a physical sensation. It's a complex experience shaped by the brain's interpretation of signals from the body. As Dr. Huberman might describe, pain is like a conversation between your nervous system and your brain, influenced by sensory input, emotions, and cognitive processes. For example, a minor injury like a stubbed toe might feel excruciating if you're stressed, but barely noticeable during an intense basketball game. This variability highlights the brain's role in modulating pain. The nervous system detects potential harm through specialized sensory neurons called nociceptors, which send signals to the spinal cord and brain when activated by stimuli like heat, pressure, or chemical changes. However, the brain doesn't just passively receive these signals. It actively interprets them. Huberman would likely emphasize that the brain's processing involves multiple regions, including the somatosensory cortex, which maps where the pain is coming from, the insula, which integrates sensory and emotional aspects, and the prefrontal cortex, which evaluates the pain's context and meaning. Acute vs. chronic pain. Pain comes in two primary forms, acute and chronic. Acute pain, like the sharp sting of a cut, serves as an immediate warning signal to protect the body. Huberman might explain this as an evolutionary mechanism. Your brain screams, "Move your hand away from that hot stove." Chronic pain, however, is different. It persists beyond the healing of an injury, often becoming a condition in itself. For example, someone with chronic lower back pain may feel discomfort long after the initial injury has healed, driven by neural pathways that have learned to maintain pain signals. This persistence is tied to the brain's plasticity, which we'll explore later. Chronic pain affects over 1.5 billion people globally, and Huberman would likely point out that it's not just about tissue damage, but about how the brain and nervous system amplify or sustain pain signals. For instance, conditions like fibromyalgia or neuropathic pain often involve heightened sensitivity in the central nervous system, a phenomenon called central sensitization. The role of emotions and context, the brain's interpretation of pain, is heavily influenced by psychological factors. Stress, anxiety, or depression can amplify pain perception by activating the amygdala, the brain's emotional hub, which associates pain with fear or distress. Huberman might share an example. Imagine two people with identical knee injuries. The one who's stressed about work and finances might rate their pain as an 8/10, while the other, who's relaxed and optimistic, might rate it as a 4/10. This difference arises because the brain's limbic system modulates pain signals based on emotional state. Conversely, positive emotions can dampen pain. Huberman often cites studies showing that laughter or social connection can trigger the release of endorphins, the body's natural painkillers. For instance, watching a comedy show might temporarily reduce the discomfort of a headache. This interplay between mind and body sets the stage for understanding how mental states can influence physical health and recovery. The mind-body connection, mental states and physical health. Defining the mind-body connection, the mind-body connection refers to the interplay between mental states, thoughts, emotions, and beliefs, and physical health outcomes. As Huberman might explain, your brain is not just a control center for your body, it's a dynamic system that shapes how your body functions. For example, when you're stressed, your brain signals the release of cortisol, which can suppress immune function and slow wound healing. On the flip side, positive mental states, like feeling supported or engaged in meaningful activities, can boost immune response and enhance recovery. This connection is rooted in the autonomic nervous system, which regulates involuntary functions like heart rate, digestion, and immune activity. Huberman would likely highlight the role of the vagus nerve, which acts as a superhighway between the brain and body, mediating stress responses and promoting relaxation. By understanding this connection, we can use mental strategies to influence physical outcomes. Historical and cultural context, the idea that the mind influences the body isn't new. Ancient practices like yoga, meditation, and traditional Chinese medicine have long recognized the link between mental and physical health. Huberman might reference modern pioneers like Dr. Herbert Benson, who studied the relaxation response, or Dr. John Sarno, who argued that unresolved emotional stress could manifest as physical pain, e.g., tension myoneural syndrome. These ideas align with neuroscience's growing understanding of how mental states affect physiological processes. For example, Huberman might describe a study where patients with chronic pain who practiced mindfulness-based stress reduction, MBSR, reported significant reductions in pain intensity. This suggests that by calming the mind, we can modulate the body's pain signals. The video likely emphasizes that these ancient insights are now backed by rigorous science, making them more accessible and actionable. Emotional impact on healing emotions play a critical role in recovery. Huberman often cites research showing that patients with positive outlooks recover faster from surgeries or injuries. For instance, a 2018 study in the Journal of Psychosomatic Research found that optimistic patients undergoing heart surgery had shorter hospital stays and fewer complications than pessimistic ones. This may be due to lower stress hormone levels and enhanced immune function in those with positive mental states. Social connection also matters. Huberman might share an anecdote about a patient recovering from a broken leg who heals faster because they are surrounded by supportive friends and family. This social support reduces stress, which in turn promotes the release of oxytocin and other healing, promoting hormones. The video likely underscores that fostering positive emotions and social bonds can be as crucial as physical therapy in recovery. Practical implications: the mind-body connection suggests that we can actively influence our health by managing our mental states. Techniques like deep breathing, visualization, or cognitive reframing can reduce pain perception and accelerate healing. For example, a person with arthritis might use guided imagery, visualizing their joints as flexible and pain-free to reduce discomfort. Huberman would likely emphasize that these strategies work by modulating the brain's pain pathways and stress responses, setting the stage for the discussion of neuroplasticity. Neuroplasticity, rewiring the brain for pain management and healing. Understanding neuroplasticity. Neuroplasticity is the brain's ability to reorganize its structure, functions, and connections in response to experience, learning, or injury. As Huberman might explain, your brain is not a fixed machine. It's more like a garden that you can cultivate. This adaptability is key to managing pain and promoting healing. For chronic pain sufferers, neuroplasticity can be a double-edged sword. The brain can learn to amplify pain signals, but it can also be trained to dampen them. Neuroplasticity involves changes at the synaptic level, where neurons strengthen or weaken connections based on activity. For example, if someone repeatedly focuses on their pain, the brain may strengthen the neural pathways associated with that pain, making it feel more intense. Conversely, by engaging in activities that distract from pain or promote relaxation, those pathways can be weakened, reducing pain perception. Neuroplasticity and chronic pain. Chronic pain often involves maladaptive neuroplasticity, where the brain becomes wired to sustain pain signals. Huberman might describe this as a neural habit that the brain has learned, like a song stuck in your head. The video likely explains that techniques like mindfulness, cognitive, behavioral therapy (CBT), or graded motor imagery can help rewire these pathways. For instance, a patient with phantom limb pain might use mirror therapy, where they visualize their missing limb moving in a mirror to retrain the brain and reduce pain signals. Huberman would likely emphasize that neuroplasticity is experience-dependent. Engaging in consistent, deliberate practices can reshape the brain's pain responses. For example, a 2020 study in Nature Reviews Neuroscience highlighted how mindfulness meditation can reduce activity in the default mode network DMN, a brain network linked to rumination and chronic pain. By quieting the DMN, individuals can break the cycle of pain amplification. Neuroplasticity and healing beyond pain management. Neuroplasticity can accelerate physical healing. Huberman might cite research showing that mental practices like visualization can enhance recovery from injuries. For example, athletes who visualize successful movements during rehabilitation, e.g., imagining a strong, pain-free knee, often recover faster than those who don't. This is because visualization activates the same motor circuits in the brain as physical movement, strengthening neural pathways that support healing. The video likely highlights that neuroplasticity is most effective when practices are consistent and intentional. Huberman might use an analogy. Think of your brain like a muscle. The more you train it with positive, healing, focused activities, the stronger those neural circuits become. This leads to the practical strategies viewers can use to harness this potential. Practical strategies: using the brain to manage pain and promote healing. Mindfulness and meditation. One of the most powerful tools for pain management is mindfulness meditation, which involves focusing on the present moment without judgment. Huberman might explain that mindfulness reduces activity in the brain's pain-amplifying regions, like the amygdala, while increasing activity in the prefrontal cortex, which helps regulate emotions. A practical approach might involve a 10-minute daily practice where you focus on your breath, noticing sensations without labeling them as painful. For example, someone with chronic migraines might sit quietly, breathe deeply, and observe their headache without reacting to it. Over time, this can reduce the emotional distress associated with pain, making it feel less intense. Huberman might cite a 2016 study in the Journal of Neuroscience showing that mindfulness meditation reduced pain intensity by 24% in participants. Cognitive behavioral techniques. Cognitive behavioral therapy (CBT) is another evidence-based strategy. CBT helps individuals reframe negative thoughts about pain, such as "this pain will never go away," into more constructive ones, like "I can manage this pain with the right tools." Huberman might suggest a technique called cognitive restructuring, where you identify catastrophic thoughts about pain and replace them with realistic, empowering ones. For instance, a person with arthritis might journal their thoughts about pain, noting when they feel hopeless, and then challenge those thoughts with evidence of times they've successfully managed discomfort. This rewires the brain's cognitive response to pain, reducing its emotional impact. Visualization and guided imagery. Visualization involves imagining positive outcomes or sensations to influence the brain's pain and healing pathways. Huberman might describe a technique where you visualize your body healing, e.g., picturing a broken bone knitting together or inflamed tissue calming down. This activates neural circuits associated with healing, potentially speeding up recovery. A 2019 study in Sports Medicine found that athletes using visualization during rehabilitation had improved muscle strength and mobility compared to controls. A practical example, a patient recovering from surgery might spend 5 minutes twice daily imagining their incision healing smoothly, visualizing healthy tissue forming. Huberman would likely emphasize that consistency